we speak about energy is important, but also time is more important. So I'll be very short. So I will speak about, I'm Igor Mishkovski, I'm assistant professor at the Faculty of Computer Science and Engineering, also known as PE, Macedonian language. And I will speak about the enabling role of ICT for fully electric vehicles. So the first slide is just some introduction. So we have the transfer between the second and the third generation. Now we have the third generation of electric vehicles. There are some characteristics. The part which is interesting for me is the ability to program the car through use of iPhone application, which is very interesting from the information science. And also other characteristics like the horsepower, increasing horsepower, and bigger acceleration. So this made the penetration of electric vehicles in the European car market pushes more and more. So how the electronic vehicles impact on power grid? They could play a central role in decarbonizing the road transport, but on the other hand, we have a problem because they will additionally have bigger impact on peak loads, as motorists or drivers usually want to recharge their batteries during the evening. So if I have an electric car, when I return at home, I will immediately put my electric car for recharging, and I will even more increase the daily peaks. So the electricity suppliers will need to anticipate the long term. This may switch out from smartphone application. I speak about smart grid, but then I will connect the whole things. So the electricity suppliers will need to anticipate this, the long-term investments that will be needed to respond to this emerging trend. So the promising technology is the smart, as I can say, technology is the smart grid technology, which can enable a grid-to-vehicle charging, and by this the load will be shifted to the off-peak periods, and we will have a flat daily load curve. And by this, the electricity suppliers will significantly reduce both the generation and the network investment needs. So the ICT is very important. That is a significant enabler of the smart grids through major communications, data collection, which is very important, analysis, billing, etc. And using also the additional renewable resources like wind and solar power generation, the smart grid has the potential to match the demand with the supply through some dynamic pricing structure. So the smart grid can connect the uncertainty of these renewable resources with the consumers on the other side. So they will have some equilibrium state in the power grid. And as I said, the electric vehicles will have an important part to play in the future to suck up the energy when the prices are low. So this is the most important part for the electric vehicles, to use the electricity when its price is the lowest. Here are some statistics. These are very optimistic statistics that, for example, Israel, which is a big supporter of the electric vehicles, as I saw, it's predicted that in some time there will be half of the load will be on electric vehicles, and Israel will be the first country on electric vehicles. But these are optimistic projections, and one of the most optimistic for commercialization of electric vehicles is that by year 2050, electric vehicles would add 20% of the today's electricity demand. So this is a good thing, but it's also a problem because commuters, as me, as I said, will typically want to recharge the battery on returning home in the evening, and coinciding with the normal daily peak in the load. There has to be some modeling, there has to be some engineering that will model the power grid, the renewable resources, and the consumers on the other side, and also the electricity markets, in order to have some financial incentive and means to schedule the charging during the night when the overall system is at low peaks, is much lower. So here are some possible solutions. So for example, we can use smart charging or plug-in vehicles under driving behavior uncertainty. So to use some probabilistic traffic models. And the other solution is to integrate, and there's also a third, the mobile phone. The other solution is to integrate electric vehicles in smart homes. So if everybody has a smart home, so we could easily integrate these vehicles into our smart home. The probabilistic traffic model, I will not speak into details, but the idea is the goal is to create possible realization of the mobility patterns of some example situations. So we have to have the data first, to collect the data, and then to do some analysis in order to create possible realizations of these mobility patterns. And the mobility patterns, by definition, are the data will be the set of the trips, the timing, the duration, the energy consumptions, the mean of the purpose of these trips, the destination location, etc. And we want to model individual driving behavior. So we can define different states, for example. This is just an example. We can define, for example, a driving state and a park state. Then the park state can be different. Can be, for example, parked at home, parked at some leisure center, parked at a shopping location, or at work. And when we have these states, we can set some parameters conditional on the state. For example, only home charging of the electric vehicle is applicable. Or for example, if you want to charge the vehicle in the commercial side, then the price is much higher than charging at home, etc. So after based on these states and the possible state transitions between states, we can easily build continuous time non-Markov chain, where the one state depends on the other state, so it's a non-Markov chain. And using this framework and using some Monte Carlo simulations, we can differentiate the samples of mobility patterns for each vehicles. Based on this, then we conclude the demand profile of the vehicles, which can be optimized. So this is just some how modeling can help this problem with charging the electric vehicles and overloading the grid. The second possible solution is, for example, to have a smart home, and we have a smart home management device in our home. We have the combined heat and power, for example, station. We have the solar energy. We have this dumb home appliances. Then we have the battery electric vehicles. This is the energy management panel, where each consumer can, for example, program the charging of the vehicle, or it can easily be connected to the Google calendar, my Gmail calendar. It will recharge it. If, for example, tomorrow I will stay at home, it will not recharge. Even the human interaction is not so important. And also the utility companies we have here. So the idea is the resident can monitor the current state of the charge, the current charging, check the time when the electronic vehicle will be ready, check and change the configured departure time, etc. So the possibilities are great. And the addition to this is that the electric vehicle will not only be just the load of the power grid, it will also be like I don't know if before I was not here, so I don't know if the presenter speak about this before. It can be also the energy storage system, which will be able to feed back the energy when it's needed by the dumb appliances, let's say. Or another good thing is this was the Tesla dream, so we can transfer the energy from our vehicle to another vehicle very easily. Even we can sell this. So also some business models are possible. And the third part is the smartphone applications. So there exists this one smartphone application which I found. So the electric vehicles really need this kind of application because they will be highly interactive with the grid. So the cars cannot possibly work if they are dumb appliances, and if all, as I said before, all plug in the car when they return from the work. So charging has to be somehow spaced out, done mostly at the night. Nobody will ask, like a driver wants to wake up at 2 AM and recharge his battery. So this is why the mobile phone or the mobile application is very useful for this. So we can, the car will talk with my software. It doesn't have to be a mobile application. application, so with my software, and we'll negotiate about the time when it's more appropriate to fill the tank, to charge the battery, and it will start charging session at the optimal after hours time when the peak is low. Also, we can use also the cell phone to initiate the station. We can negotiate with the utility, but also if the energy is urgent, we can do this. When we are checking the rest, we will have a ping that the car is filled, that is charged, and it can provide information about the car state, battery car state, expected completion time, and maybe a crowdsourced location of charging stations. Also, it's good to have like a cloud solution where I know other electrical cars which are close and how much they are charged. For example, if I drive 130 kilometers and in 10 kilometers more, I can pay easily this and use some other battery from other car. Just as a conclusion, so it all started with Ferdinand Porsche with the Volkswagen Beetle, and he used electrical car using wheel motors and provided 50 kilometers of range. This was strange for me because it's 1897, so it's a little bit like here's the star. I think it should be 6th star because it's strange how we are not everybody on electrical vehicles. But now we have software is one of the major driving components behind the automotive innovation. So today 80% of the innovations in the cars have come from the ICT industry, so from the domain of computer systems. And the future will be even more because some of the possibilities is better energy cost efficiency, so optimization at system level, intelligent predictive control, zero accidents, which we want, like proactive safety functions, and then seamless connectivity, so integration with my mobile device and other embedded devices, interaction with the cloud where I put the data, and then the utility company can easily analyze this data and make some, change something in the power grid. We can have software updates over the air, etc. So I think that ICT part in this automotive it's very important. So this was my talk. I hope I was interesting, and thanks again. If you have any questions.